Count the complete subarrays in an array. You're given an array nums consisting of positive integers. We call a subarray of an array complete if the following conditions are satisfied. The number of distinct elements in the subarray is equal to the number of distinct elements in the whole array. Return the number of complete subarrays. The number distinct. Okay, so here the whole array has 3 distinct elements, 1 through 2. The number of subarrays would be like 1 to 2 here, that's 1. 3 to 2, that's 2. 1 to the last 2, that's 3. 3 to the last 2, that's 4. Okay. So this seems like a sliding window, because if you have a minimum window whereby all the elements, all the distinct elements are included, then anything that is that or longer is going to be also a complete subarray. So I'll say, so I think we'll use a sliding, how do I want to do this? So I think here we'll use a sliding window where so the left side will be so the left side, so when I want to consider sliding windows, consider what the left side and right side are. So I think the left side will be the index of the loop. So the loop will go through all the left sides. And then the right side should be the left side is start of window is index of loop, and right side is the minimum is the earliest right index, whereby all distinct values in array are included in window. That gives the kind of smallest complete subarray for that left index, and all subarrays from that right side to the end where the index is n or n minus 1 would also be complete. So let's say an example here. If it's 1, 3, 1, 2, 2, you start with the left side being 1 and you extend it all the way until it's 1, 3, 1, 2. And you know that in that case 1, 3, 1, 2, 2 is also complete. And then you move on to 3. 3 goes, if 3 is the start, then you go to 1, 3, 3, 1, 2. And then you know that if that works, then 3, 1, 2, 2 is also complete. And then if you start with 1, 1, 2, 2 never works. Like, you can move the right side all the way to the end. So does the right side ever go backwards? I think the right side always goes forward. Yeah, the right side always goes forward. Okay, so I think here I also need to know which were the distinct elements and how many there are within the subarray, I think. how to do that. I think maybe I'll say the distinct is a set, and I'll have a frequency count. So I can use a default dictionary, I can use a set value. Since all the nums are between 1 and 2000, I'll use a set value. So counts is going to be a frequency starting with 0, and I'll say this is times, maybe I can say the largest is the max of nums, and I can maybe limit it to largest plus 1. So to get the count of the number, so to get a unique values, I'll just do the set of nums. So I really just need to care about how many uniques there are. So maybe I can just say the length of the set of nums. So for every, and let's say the answer is 0, left and right. Well, right should probably start with 0. So for every left side in the range of n, where n is the length of nums, where n is the length of nums, I'll say the value is the nums at the left side. So how does this work? So the right side will continue. So the right side will, let's say, add onto right side, increase right side of window until all elements are included, until window has all distinct values. So I think I need to have while right is less than n, and the counts and the length of the distinct is less than your uniques. And unique and distinct is just kind of confusing wording, but whatever. So the value, say right val is going to be nums at right, and I'm going to add that to my counts. So counts of right val plus equals 1. And then I can do distinct dot add this value. So it goes all the way to the until it is the it goes all the way to the end if necessary, but it goes to the minimum one that you need to add. And then your answer would be incremented by so complete subarrays starting with left index is going to be answer plus equals. This is only, so it could technically go to the end and not actually have go to the end and not technically have all the uniques. So I think I need a break in that case. So if right is equal to n and the length of the number distinct is less than the number of uniques, then you can't really do anything more. So just break. Okay, in this case, it's not that, so it has reached a point where the right side of the window includes all uniques. So it would be answer plus equals n minus right plus 1. Yeah, I think that's right. And then now you remove left side value from window. So we'll say this is the left value. So after you say that 1312 is the smallest window starting with 1, you need to remove the 1 from the window and go down to 312. So it'll be something like counts of the left value minus equals 1. If the counts of the left value is now equal to 0, then remove the value from your distinct set. And I think that's it. Alright, see how badly this fares. Time limit exceeded. Unfortunate. So I think this went infinite. Oh, the classic case of me not using the while loops correctly, or not incrementing. Alrighty, cool. Guess there wasn't much in terms of speed differences of the answers here. Is there any way to optimize this? Create your distinct set, create your unique set, or create your count. Distinct. Maybe I can say this is non-distinct. Is there a word that describes the number of distinct values? I mean, unique and distinct are just synonymous. And maybe it's whatever. Answer is equal to 0. Say right equals answer 0. Don't know if this is strictly necessary. Whatever. Break. Okay, I think this is good. Summary. So again, sliding window technique, where left side of window increments in loop, and right side is the earliest index, where all distinct values of array is found. That gives the all later subarrays from right side to n are also complete. And then we use sets and a frequency array to keep track of which values have been seen. So so we have a distinct set. For every value that we add on the right side, we add it to the distinct set. And we also keep track of the count, because the count matters if there's like multiple ones that might be added, or multiple some certain values that were added into the window. You really want to quickly see how many uniques there are, so that's why you have a set. And you want to quickly, when you remove stuff by the count, and only when the count reaches 0 of that value do you remove it from the set. So that's the quick way of doing it. The other way that you could possibly do it is really that's the best way of doing it. Like other ways would be kind of slow. Like you keep track of the count only, and then you do a separate calculation of how many unique counts there are, how many unique or not or zero counts there are, something weird like that. It's not good. Our time complexity, this is going to be O of n for going through all values. The calculation of adding things to the set or increasing the frequency is just 1. The right side always goes rightwards and never goes backwards. So the right side also goes to n, while left side goes to n once. Right side only increases, so up to so inner while loop will execute n times at most. Well, n times exactly. And then base complexity, this is going to be O of n for O of n at most, O of v, where v is the number of values, so, or the number of unique values. So here the description was n is 1,000. I did make a array that was of size the largest. So in theory, if using a dictionary, then it would be possibly smaller O of n, because n is the length of the array is actually smaller than the possible range of values, where I used a 2D mapping